Okay guys, so this is going to be my video on advanced programming concepts, and for this one I'm going to show what I did to get my animation going for my snake game. Um, so what basically is I created a canvas, and on this canvas I was gonna draw everything. I was gonna use render to draw in the canvas. So as you can see, we use this get draw graphics here that comes from the buffered strategy. Buffered strategy is a class that from Java library, as you can see here, image.bufferedStrategy. And we also need the thread to make the compiler the compiler works only, well, besides working on the logic of the game on the compiler itself, it's gonna set a new thread only to work on the rendering, so the rendering doesn't get it cannot be stopped. I mean, it keeps on going. You need a thread only working on that. So as you can see here on my render on my render method, I have the buffer strategy. We access display. We create a new display right here, right? First we initialize everything. We initialize the display. We initialize the key listeners, and then we initialize the apple and the snake. And this is going to be initialized here in a run. So this is when the game runs. We initialized right here, and then we set the frames per second to 60. And this is a calculation that I don't understand fully, but I understand a little bit. So we use 1 billion nanoseconds, because that's, you have 1 billion nanoseconds instead of a second, and then you divide those to make it really smooth. Some of you saw how my snake moves. It is really smooth. So to do that, you need like to get the nanoseconds, and then you divide it by the frames per second. This is frames per second in 60 is just a standard frames per second. Like most of the games, 2D games use 60 frames per second. If you play like at more greater games, like it's gonna be higher, but most 2D games use 60 frames per second. Then I set a variable called delta to 0. Delta is what is gonna be telling the game to either update the game and draw the game every time the current time is and the last. So the difference between the current time and the last time would be like the current time, like 1 second before, and then delta is going to be that divided by time per tick. Time per tick is going to be that what I told you, like that 1 billion nanoseconds divided by the frames per second. It is really complicated. I don't have enough time to explain in 5 minutes fully, but basically that's what it is. We got the current time, and then we take the difference of the current time and the previous current time, and then we divide it by this right here, and that gives us delta. And if delta is greater than or equal to 1, we update the game, we draw the game, and then we take that 1 from the delta, so it's gonna update again. So then we're gonna have the current time, and then the previous current time and the last time, and then we're gonna divide it again. So that's like the loop of the game. That's gonna keep running. That's gonna keep happening. And on the render here, what I did was I get the canvas, and then I get the buffer strategy. Well, BS is gonna be the buffer strategy of this canvas, and then if this buffer strategy doesn't exist, we're gonna create the buffer strategy with 3 buffers. As I said before, you can use as many as you want, but 3 is like the optimal one for a 2D game. And then we're gonna return it. Then so G is gonna be so G is like a variable that is used to draw. So it's like a pen. Let's say it's a pen, right? So it's like the pen and the color we choose. It's everything inside of the render method. So G get draw graphics. So we start like get the pen, right? And then create a rectangle. This is gonna be the screen behind everything. The screen to draw everything. Then we're gonna set the color to white, and then we're gonna draw the string. And then we're gonna call apple.render. I could write in here like set color to red and fill rectangle 1010 and then random width, random height. I could do that, but it's just easier to use the render from the correct place, which is gonna be here. So set color red and random position. So fill rectangle X and Y size, which we use a random. If we go right here, we use this random number and we apply it on the apple when we create it. And then when it eats the apple, updates again. So rendering is always drawing, while the logic can happen in other places, but this is always gonna happen. So we always gonna render the apple. We're gonna keep updating that here. So this is the update of the game. So every time the apple is eaten, right, it's gonna be checking. Was the apple eaten? Was the apple eaten? Okay, it was. Alright, cool. So if it was, we're gonna add a new segment to the snake and the random number on the X and the Y of the apple. So it's a little confusing. I'm 7 minutes and 30 seconds. I don't know if it's possible to explain this in 5 minutes, but I could explain way better. It's just I ran out of time. But I hope you guys understood like the basics. If you didn't understand on the first time, just rewatch the video and then search for some of this stuff online. This is not the only way to create a game. As I told you in the class, I created the game in another way too. It just I couldn't apply the logic and the drawing all together perfectly, so I had to look it up how to do this, and I found this concept, and it's really good. I looked it up on many websites and Stack Overflow and everything, and it's a good way of creating a game, but it's not the only one. There's so many other ways, but this one is a really good one. If you guys want to create your own games, just go over this code right here. I'm gonna post the code too, and then you can go over, you can understand what is happening. And yeah, well, I hope you guys understand. Thank you.